Okay, picking up where we left off on page 24, we're talking about the OSI model. I told you the mnemonic for starting at layer 1 going to layer 7. There's another one starting at the top going down. All pizza served today needs double pepperoni. So if you want to think of it from 7 to 1 or 1 to 7. Anyway, cool ways to remember how these things go. So let's compare the two models we just saw. We saw the TCP/IP model, and now we saw the OSI model. So let's kind of see how they line up. And they do not line up exactly. The physical layer, no problem. Data link, no problem. Network, transport, a little bit of overlap. The session layer was really designed for, I have multiple things going on simultaneously. And so I may have to separate some multiple sessions. Like I have two browsers. That's a stupid example, but I have two browsers open, so they're all using the same transport, but the packets have to figure out which one is on browser 1 and which one is on browser 2. So TCP basically doesn't have that issue. They just assign port numbers, and so it's kind of like the lines in the middle. We don't really do a presentation layer in TCP. It's just not the way it works. Again, OSI was designed to be a logical model, not a physical implementation. So this is the physical implementation that handles all of that. So yes, there'll be some good test questions out of that kind of stuff later. I mean, not now, but okay. So some people just view TCP/IP as a simplified OSI model. That's not exactly correct. It is an implementation, a physical implementation of the OSI model. It's not a simplified model because it's not a model. It's an honest-to-God implementation. Okay, cool? All right, on page 27, they talk about internet protocols. And so right off the bat, what the heck is a protocol? And no, it's not a Goldie Hawn movie. Protocol is a good definition of protocol is a set of rules that both of us adhere to so we can communicate. A good example is in early days of aviation. Everyone had to agree to be on a certain traffic control radio frequency. Everyone had to have the same frequency, because if I'm operating on some frequency and France and Germany are operating on some other frequency, we've got a problem. And then what happened was they said, we're starting this revolution, so therefore all traffic controllers have to speak English. So that became the rule. Here's the set of frequencies that we're going to use to talk, and all traffic controllers have to speak English. So that's a protocol. Here's what you have to do to be able to talk. And so for us to talk together, we have to follow rules. That's essentially what a protocol is. A set of rules. Typically, the protocols occur laterally. In other words, they only occur between physical layer and physical layer, or data link layer and data link layer, or network and network. Okay, protocols don't normally go vertically along the model or the physical implementation layers. They typically just go from side to side, so to speak. Okay. Again, we talked about there's two major functions that this protocol, IP protocol, is all about. One is that interoperability. I can basically swap out a layer. I could swap out this physical layer. Remember, the physical layer was like whether or not I was using a fiber optics cable or an Ethernet cable. I could swap that out and everything else would remain. Okay, I could swap out Wi-Fi or fiber, and it would just continue to run. Okay, this is a good way of thinking about the IP protocols. The protocols are designed to handle basically everything, and in fact, it's kind of designed to fulfill the needs that we don't even know about yet. Okay, that's a good way of thinking about it. Here's some examples of this using the TCP/IP physical layer, not the OSI logical model. Okay, cool. So here's the physical layer, and here's some choices. So I could have fiber optic, I could have physical Ethernet cable, I could have the old style phone modem, I could have a honest-to-God cell phone, and then I have my choices. An MPLS circuit, or frame relay, or Ethernet, or wireless, or asynchronous. Anyway, we'll talk about it. And then IP is kind of the big boy in the middle. And then there's two different choices for for transport. One's designed to make sure you got it. That's the TCP, and one's designed it's okay if you didn't get a piece. In other words, we're just blasting it to you, and if you miss one, it's no big deal. That's under UDP. And then all these layers. I mean, applications. You have the web layer and the email and file transfer and remoting and instant messaging and voice over, blah, 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 blah. The whole point is this thing was designed so you could just add another application on. Now, some people call this the thin waist model because it curves in where there's an awful lot of choices at the bottom, right? I could have fiber optic, I could have this, that. I could add another one without too much trouble, right? If somebody came up with, a laser, transport physical layer, they could just pop it in there with no trouble. If somebody added something at the top, no trouble. As long as you're adding to the top or the bottom, you're okay. Things in the middle, not so much. There's really, you can't really swap this guy out. The IP guy in the middle, yeah, he's kind of the star of the show. He's the one that basically says, here's how you get a packet from point A to point B. And everyone's using it now. And when it comes time to swap that guy out, there's an awful lot that has to happen. Now, we did this not too recently, a time ago. And that's when we were running out of IP addresses. We had this old style IP address, and you may have heard of IPv6, maybe. And they doubled the size of the IP address range. So we were running out of IP addresses, and now we have a gazillion more than we could ever use. And so that was tedious. It took years of planning. All the manufacturers had to get together and agree. All the people had to say, okay, now next Tuesday we're going to throw the switch and we're going to start doing, IP6. And, it was a big deal. So swapping these guys out is trivial. Swapping that guy out is anything but trivial. Okay, cool. Let's continue. We're almost done. On the next page, they talk about the typical network. And we've seen this little diagram. We've seen it before, but just one more time. So my home PC, and then I've got some stuff here. I have a wireless router, and again, we're going to go over the alphabet soup a little later. But it has DNS, and it has DHCP. Again, don't worry about what that means just yet. I probably have a cable, or maybe a fiber optic cable, that connects to, like in this case, Verizon's internal network, and they want to talk to Cogent's network. And so there's a peer-to-peer connection between these backbones, and it's called the peering point. So when one backbone wants to talk to another backbone, that's how that works. And then there's probably a fiber optic cable coming into the campus, and then there's a campus backbone, and perhaps a department backbone or a building backbone, and then there's a web server. So that's how all that works. Okay, there's a summary on page 30. I'm not going to go through it, but I would recommend you do to make sure you kind of picked up on all the key points. All right, ladies and germs, this is essentially the end of the chapter, and hope you guys learned something, and we're going to see you again in the next chapter.